እንዴት ናቸው የዩቲዩብ ቻናል ቤተሰቦች? በዚህ ቪዲዮ የ2016 በሞዴል የተፈተናችሁትን ጥያቄዎችን አብረን እንሰራለን። ጥያቄዎችን በሁለት ከፋፍዬ ዲቴል ካልኩሌሽን የሚፈልጉ ፓርቶች አሉ፣ እነሱን በቀጣይ ፓርት ሰራለሁኝ። ይሄ በቲዮሬቲካል እና ሞር ኤክስፕላኔሽን የሚጠይቁ አንዳንድ ደግሞ የካልኩሌሽን የሚፈልጉም ጥያቄዎችም የተሰሩ አሉ። ስለዚህ ቀጣይ ፓርት የቀረው በቀጣይ ፓርት አቀርባለሁ። አሁን ኢንዲቴል ኤክስፕሌን ማድረግ ያለብኝና አንዳንድ ደግሞ በካልኩሌሽን መልክ የማቀርባቸውን ጥያቄዎች አሉ። የተወሰነ ጥያቄ በዚህ ቪዲዮ ሰራለሁኝ። ሌላ አብዛኛው ጥያቄ የአምና ኤግዛም ብዬ ባቀረብኩት ጥያቄው ላይ ፓርት 1 እና ፓርት 2 አለ። እዛ ላይ የተሰሩ ስለሆኑ አንዳንድ ሞዲፊኬሽኖች አሉ። እነሱን ጭምር በዚህ ቪዲዮ ሞዲፋይ የሚደረገውን በዚህ ቪዲዮ ሰርቻለሁኝ። ያለውን ደግሞ ተመሳሳይ የሆነውን ከዚህ በፊት በሰራው በሁለት ኤግዛም ጥያቄዎች ላይ ሰርቻለሁኝ። ይሄ ቪዲዮ ፓርት 1 እና ፓርት 2 ያላያችሁ ዲስክሪፕሽን ቦክስ ላይ ወር በዚህ ቪዲዮ ዲስክሪፕሽን ቦክስ ላይ ሊንኩን አስቀምጣለሁ። ከዛ ውስጥ ገብታችሁ ማግኘት ትችላላችሁ። አሁን በዚህ ቪዲዮ ወደሚሰራላችሁ ጥያቄዎች ልግባ። የመጀመሪያ ጥያቄ which one of the following discussion is incorrect regarding the general stress strain diagram for the three type of plastic material shown in the figure below? Here we have three plastic materials as phenolic, nylon and polyethylene, and we have stress strain diagram for these three plastic materials. As this is the stress strain diagram for phenolic. This one is the stress diagram for nylon, and this is the stress strain diagram for polyethylene. So here we are asked to differentiate the incorrect statement for this stress strain diagram for these three materials. A, polyethylene is more flexible than all. Let's discuss this. When we say this polyethylene is more flexible than this, the polyethylene stress strain curve is this one, and this shows the flexibility for this polyethylene is more flexible than the others because there is no exact point in which this polyethylene starts the permanent deformation or plastic deformation. The next one is phenolic is more brittle compared to nylon. When we compare phenolic and nylon, this phenolic is more brittle. This is also true. This is also true because here phenolic, the maximum stress that the material phenolic phenolic is more brittle compared to nylon. This is correct. This is correct because the point at which this phenolic started is permanent formation at here, whereas nylon started is permanent formation at this point, at this area, because this is the maximum strength of the material or nylon material at which it can withstand before any permanent deformation. So the maximum or the stress at which this nylon starts, this is permanent deformation is at this point. So this is the stress for the maximum stress that the nylon we can withstand before any fracture, any permanent fracture, whereas phenolic starts its permanent deformation at this point. Therefore, here we compare this phenolic with nylon, it's more brittle than that of the nylon because it begins permanent deformation that of the faster than that of the nylon, So this is the correct statement. The next, nylon is more brittle compared to polyethylene. This is incorrect statement. Incorrect statement. When we compare this, the stress strain diagram of this polyethylene and nylon, here the polyethylene starts deformation at this point. Polyethylene starts deformation at this point, but this nylon starts deformation at this point. That means this polyethylene is more brittle than that of nylon. The maximum stress that polyethylene can withstand before any permanent fracture is at this point, but in case of nylon, the maximum stress is at this point. Therefore, in this case, this nylon is more brittle compared to polyethylene. It is false, but polyethylene is more brittle than nylon. This is the correct statement. Therefore, the correct answer for this question is C. C is incorrect. in plant layout where similar equipment and material operation are grouped together in the function layout is A. Process layout, B. combination layout, C. fixed position layout, D. product layout. So basic case maybe industrial management and engineering economics like chapter 2 ላይ ነው ያለው plant or facility layout የሚለው ሁሉም ዩኒቨርሲቲዎች ተመሳሳይ ስለሆነ ቻፕተር 2 ላይ ነው ያለው። ስለዚህ ቻፕተር 2 ላይ የተለያዩ የፕላንት ላይአውት ታይፖች አሉ። ከነዛ ውስጥ አንዱ ፕሮዳክት ኦሪየንትድ ፕላንት ላይአውት፣ ፕሮሰስ ኦሪየንትድ ፕላንት ላይአውት፣ ፊክስ ፖዚሽን ፕላንት ላይአውት ኤንድ ኮምቢኔሽን ኦር ፊክስ ኦር ኮምቢኔሽን ኦር ሚክስቸር ፕላንት ላይአውት ብለን ግሩፕ እናደርጋለን። ሜቢ ይሄን ክላሲፊኬሽኑን ኢን ዲቴይል በዚህ ዩቲዩብ ቻናል ስለዚህ የሚያወራ አንድ ቪዲዮ አለ። ከዛ ውስጥ ገብታችሁ ማየት ትችላላችሁ። ከፈለጋችሁ የቪዲዮን ሊንክ በዚህ ዲስክሪፕሽን ቦክስ ላይ አስቀምጣለሁ። So when we say process oriented layout, in this type of layout, in process oriented layout, the machines or the equipments or the machines are grouped based on their function. So ተመሳሳይ ስራ የሚሰሩ ማሽኖቹን አንድ ቦታ ላይ አስቀምጠን based on their function ኦፕሬሽኑን የምንሰራ ከሆነ this is process oriented layout ነው። ኮምቢኔሽን ላይአውት የምንለው ደግሞ የፕሮሰስ ኦሪየንትድ እና የፕሮዳክት ኦሪየንትድ ፕላንት ላይአውት ታይፑን የሁለቱን አድቫንቴጅ ወስደን ዲስአድቫንቴጁን ቀንሰን የምንሰራበት ፕላንት ላይአውት ታይፕ that is ኮምቢኔሽን ብለን እንጠራለን። ፊክስ ፖዚሽን የምንለው ደግሞ እኛ የምንሰራው ፕሮዳክት አለ። ያ ፕሮዳክት የሚሰራበት or ያ ፕሮዳክት በሚሰራበት ቦታ ላይ ፊክስ ሆኖ then አስፈላጊ ማቴሪያሎችን የምናጓጉዝ ከሆነ that is fixed position plant layout እንላለን። ፕሮዳክት ኦሪየንትድ ፕላንት ላይአውት የምንለው ደግሞ የፕሮዳክት ፓዝ አለ። ማሽኖችን ፕሮዳክት ፓዝ ተከትለን ኢንስቶል የምናደርግ ከሆነ or ግሩፕ የምናደርግ ከሆነ ፕሮዳክት ኦሪየንትድ ፕላንት ላይአውት እንላለን። so in this case በዚህ ኬስ የተጠየቅነው a plant layout where similar equipment and similar operations are grouped together. so ተመሳሳይ ስራ የሚሰራ ማሽን እና ተመሳሳይ ስራዎቹ አንድ ቦታ ላይ ግሩፕ የምናደርግበት ፕላንት ላይአውት ታይፕ ምን አይነት ነው ይላል። ስለዚህ ለዚህ ትክክለኛው መልስ ፕሮሰስ ኦሪየንትድ ፕላንት ላይአውት ላይ ነው እንደዚህ የምናደርገው። ፕሮሰስ ኦሪየንትድ ፕላንት ላይአውት ላይ ማሽኖቹን based on their function ግሩፕ እናደርጋለን። ፎር ኤግዛምፕል የተለያዩ ማሽኖች ካሉ ለምሳሌ በሾፓችን ውስጥ ያሉ ማሽኖቹን እንደ ምሳሌ ብንወስድ ሌዝ ማሽን ሊኖር ይችላል፣ ሚሊንግ ማሽን ሊኖር ይችላል፣ ዘን ድሪሊንግ ማሽን ሊኖር ይችላል፣ ከቲንግ ማሽን ሊኖር ይችላል። ሶ እነዚህ አራቱን ኦፕሬሽን ተጠቅመን አራቱን ማሽን ተጠቅመን የምንሰራ ኦፕሬሽን ካለ ያ ኦፕሬሽን ስንሰራ ሌዝ ማሽን በአንድ ቦታ ላይ፣ ድሪሊንግ ማሽን የሆነ ቦታ ላይ፣ ዘን ሚሊንግ ማሽን የሆነ ቦታ ላይ፣ ካቲንግ ማሽን የሆነ ቦታ ላይ አስቀምጠን ማሽኖቹን በተመሳሳይ ስራቸው ደርድረን አስቀምጠን ዘን የምንፈልገው ስራ ወደ ማሽኖቹ እየሄድን የምንሰራበት ሲቹዌሽን ነው ማለት ነው። so this type of plant layout is usually process oriented plant layout ብለን እንጠራለን። ትክክለኛው መልስ process oriented plant layout ነው። ቀጣይ ጥያቄ maybe ይሄን ጥያቄ በፓርት 2 ቪዲዮ ላይም ሰርቻለሁ። which one of the following is known as corrective maintenance? which one of the following is known as corrective maintenance? A. preventive, B. predictive, C. breakdown, D. scheduled maintenance. so from this one which one is said to be or known as corrective maintenance? ስለዚህ እኛ ሜንቴናንስ ከፋፍለን ስናይ የተለያዩ ሜንቴናንስ አይነቶች አሉን። ከዛ ፕሪቨንቲቭ ሜንቴናንስ ምንለው ማሽን ፓርት ላይ ፌለሪቲ ኦከር ከማድረጉ በፊት የምንሰራው ሜንቴናንስ ምንም ማሽኑ ሳይበላሽም ሊሆን ይችላል። ፌለሪቲ ኦከር ከማድረጉ በፊት ማሽኖቹን ሜንቴን የምናደርግበት ሲስተም ፕሪቨንቲቭ ሜንቴናንስ ብለን እንጠራለን። ማሽኖቹ ፌል እስከሚያደርጉ ሳንጠብቅ ማሽኖች እየሰሩም የሆነ ሰዓት ላይ እየሄድን ሜንቴን የምናደርግ ከሆነ that is preventive maintenance ብለን እንጠራለን። so this is what proactive maintenance type ብለን ነው የምንጠራው። this is proactive maintenance rather than corrective maintenance። ስለዚህ ይሄ corrective maintenance አይደለም። ሌላ predictive maintenance የምንለው ደግሞ this is also proactive maintenance። አንድ ማሽን ላይ ፌለሪቲ በምን ያክል ጊዜ or መች ኦከር እንደሚያደርግ ፎርካስት አድርገን በዛ ሰዓት ላይ ሜንቴናንስ ለመስራት ስኬጁል የምንወጣበት ከሆነ that is predictive maintenance ብለን እንጠራለን። this is what forecasting the process of forecasting maintenance activity when it will occur and that is what proactive maintenance ነው። ይሄም proactive maintenance ማሽኖቹ ፌል ከማድረጋቸው በፊት ሜንቴናንስ የምናደርግበት ጊዜ ስኬጁል ለማድረግ የምንጠቀመው ሜንቴናንስ ታይፕ that is also proactive maintenance rather than corrective maintenance። The other is breakdown maintenance ብለን የምንጠራው breakdown maintenance ማለት አንድ ማሽን ፓርት ኦር አንድ ማሽን ላይ ፌለሪቲ ኦከር ካደረገን በኋላ አስር ሜዳል ሜንቴን የምናደርግበት ሪፔር የምናደርግበት ፓርቶቹን ሪፕሌስ የምናደርግበት ሲስተም that is breakdown maintenance ብለን እንጠራለን. In this case usually already the failure of the machine is occur and then we are in the way of resuming the machines or the machine part by repairing the part or by replacing the part. So this is what corrective maintenance ብለን የምንጠራው, that is breakdown maintenance. Scheduled maintenance similar, it is proactive maintenance. So this the correct answer for this question is this breakdown maintenance. ሌላ በባለፈው ቪዲዮ ላይም ሰርቻለሁ, ይሄንም more clarify ለማድረግ ነው. Which one of the following is not true or not the function of fuel injection system for compression ignition machine? A, to measure or to measure the correct quantity of fuel to be injected. B, to time the fuel injection or to show the time of fuel injection. C, properly distribute the fuel in the combustion chamber. D, none. So from this one, which one is not the function of this fuel injection system? So here we have the function of fuel injection system. This fuel injection system in compression ignition engine is first to filter the fuel. Is to filter the fuel. The others to measure or to measure the correct quantity of fuel to be injected. To time the fuel injection. To control the rate of fuel injection also. To automize or to break up the fuel to fine particles and to properly distribute the fuel in the combustion chamber. So these are the advantages or the functions of fuel injection system in compression ignition engines. So from this they listed all are what functions of this fuel injection system. So the correct answer for this question is D. None of these are the function of fuel injection system, rather than all of these are the function of this fuel injection system in CI or compression ignition engines. The other is, which one of the following statements is incorrect? Which one of the following statements is incorrect about characteristics of power metallurgy? A, density can be varied with permit weight reduction. Density can be varied which permits weight reduction. B, alloy composition can be made using metallic and non-metallic chat that can not otherwise be formed. C, strength and toughness both decrease with increasing density. D, it is the best viable process for manufacturing parts from materials with poor workability. So from this, which one is not characteristics of powder metallurgy? So this is powder metallurgy is the process that we use in manufacturing parts. And this from the listed one, the incorrect about this powder metallurgy is the statement which is stated or which is expressed in choice C. Strength and toughness both decrease with increasing density, because when we are doing with metal or powder metallurgy, increasing density typically lead to improved strength and toughness rather than decreasing the strength and the toughness. So when we increase the density, that the porosity decreases, and this when the porosity of the material decrease, it results in stronger and tough parts. Therefore, statement C is incorrect. This is incorrect. The other, during the dehumidification process, dash remains constant. A, dry bulb temperature. B, wet bulb temperature. C, specific humidity. D, relative humidity. So this during the dehumidification process, the primary goal is to reduce the amount of moisture in the air. So when we perform this dehumidification process, the goal is or the target is to reduce the amount of moisture in the air. And this process typically involves cooling the air, which causes the moisture content to condense and to be removed. And however, this dry bulb temperature refers to the temperature of the air without considering the moisture content. So as such, when moisture is removed from the air through dehumidification, the dry bulb temperature of the air remains constant because the process doesn't directly affect the temperature itself. So in contrast here, other parameters such as wet bulb temperature, specific humidity, and relative humidity may change during
the humidification process or dehumidification process, because they are directly influenced by the moisture content in the air, and this dry bulb temperature represents the actual temperature of the air remains unchanged during this dehumidification process. When we say dehumidification process, it is the process in which the moisture or water vapor or the humidity is removed from the air, keeping its dry bulb temperature constant. So the correct answer for this question is choice A. Dry bulb temperature is this dry bulb temperature is constant during dehumidification process. A cantilever beam with square cross section is targeted to be designed with milled steel material having modulus of elasticity 210 gigapascal, and if the area of the beam cross section is 400 millimeter square and the total length is 600 millimeter, determine the permissible concentrated load to be applied as the free end if the maximum deflection is 5. A. The permissible concentrated load will be A. 184 Newton, B. 194 Newton, C. 204 Newton, and D. 174 Newton. Here we have given that the modulus of elasticity 210 megapascal, area 400 millimeter square, length 600 millimeter, deflection 5 millimeter, and a load P which is unknown. So to calculate this load applied on the part, we use the deflection formula. This deflection which is equal with P times L cube over 3EI, where I is the moment of inertia. Usually for square part, it is calculated as 1 over 12 times B times H cube, and this the sides of this B and H are the sides of the square. And when we calculate this area, or to calculate this B and H, we simply found this B and H from area, and area is B times H, and for square this B and H are equal, so 400 equal with BH, where this B and H are equal, and we take this B square or H square, we can take this either B square or H square, and when we put this 400 millimeter square under radical, it becomes 20 millimeter. Therefore B, which is equal with H, which is 20 millimeter, and when we substitute this 20 millimeter within this B and H value, this I becomes, or modulus of elasticity becomes 13,333.33 millimeter power of 4. And by substituting the value, this I value within this formula, I value we have given, we calculated I, L is given, E is given, then deflection is given. So the only unknown is this P, and by substituting the values, 5 millimeter, which is P into 600 millimeter, the power of 3 into, or over 3 times 210 times 10 to the power of 3 megapascal times 13,333.33 millimeter to the power of 4. So by simplifying the value, we found this P, which is equal with 194 Newton. Therefore, this the load or the concentrated load which is going to be developed on the part is 194 Newton. Therefore, the correct answer with this value is choice B is correct answer. Choice B is correct answer. This is correct answer for this specific question. The other is, which one of the following is not the advantage of adding additives to plastics? A, to enhance material property, B, to expand process stability, C, to increase environmental resistance, D, none. So from this, which one is the not the advantage? Not the advantage of adding additives to plastics. Okay, so the correct answer for this question is choice D. Choice D is the correct answer, because this adding additive to plastic can provide various advantages, including this enhancing the material's properties, expanding processability, and increasing environmental resistance for the materials. Therefore, there is no situation where adding additive to plastic wouldn't offer any advantage. So ከዚህ ከተዘረዘሩት ውስጥ ሁሉም this አዲቲቮቹን በፕላስቲክ ላይ ስንጨምር የምናገኘው አድቫንቴጅ እንጂ ዲስአድቫንቴጅ የለውም። ስለዚህ ትክክለኛው መልስ ቢ ይሆናል ማለት ነው። ጥያቄ What the first step in project planning?
what the first step in project planning? A. Establishing the objective and scope. B. Determining project constraints. C. Determining the budget. And D. Inspecting the deliverables. So here part 2 ላይ I think part 2 or part 1 ሰርቻለሁ። So in industrial management engineering economy chapter 1 ላይ about introduction to industrial organization በሚል ላይ functions of this management. So functions of management በሚለው ላይ የማኔጅመንት ፋንክሽን ፕላኒንግ፣ ኦርጋናይዚንግ አለ፣ ስታፊንግ አለ፣ ኮንትሮሊንግ አለ፣ ሊዲንግ አለ። ሶ እነኚህ የማኔጅመንት ፋንክሽኖች ናቸው። ከነዛ አንዱ ፕላኒንግ ነው። ሶ ፕላን ስንሰራ ኦር አንድ ፕሮጀክት ስንሰራ ኦር አንድ ኦርጋናይዜሽን ሊድ ስናደርግ ፕላን እናወጣለን። ሶ ፕላን ስናወጣ የምንከተላቸው ስቴፖች አሉ። በባለፈው ቪዲዮ ላይ ሰርቻለሁ። ከዛ ስቴፖቹ በቅደም ተከተል ነው የምንሰራው። ሶ ከዛ ስቴፑ የመጀመሪያ ስቴፕ ምንድን ነው የሚል ጥያቄ ነው እዚህ ጋር ያለው። ሶ ፕላን ስናደርግ ኦር ፕሮጀክት ፕላን ስናደርግ የመጀመሪያ ስቴፓችን we have to establish the objective and the scope of the project. ሶ የፕሮጀክቱን ስኮፕ እና ኦብጀክቲቭን መጀመሪያ ኤስታብሊሽ እናደርጋለን። ዘን ስኮፑን ፊክስ ማድረግ መቻል አለብን ማለት ነው። this is the first step when we are performing this project planning. the other determining project constraint ከዚህ በኋላ ነው የሚመጣው። ኦብጀክቲቭን ካላወቅን ስኮፑን ካላወቅን ኮንስትራንቶቹን ማወቅ አንችልም። ስለዚህ ይሄን የምንሰራው ከዚህ በኋላ ነው። determining the budget ኦብጀክቲቭን ካላወቅን ስኮፑን ፊክስ ካላደረግን በጀት ዲተርማይን ማድረግ አንችልም። ኢንስፔክቲንግ the deliverables ይሄንንም መስራት አንችልም ማለት ነው። ስለዚህ እነኚህ ሶስቶቹንም የምንሰራው ስኮፑን እና ኦብጀክቲቭን ሴት ካደረግን በኋላ ይሆናል ማለት ነው። so this establishing the objective and scope is the first step during this project plan. so ቀጣይ ጥያቄ ይሄንን ባለፈው ቪዲዮ ላይ ሰርቻለሁ። which of the following is not an impulse turbine? which of the following is an impulse turbine? A. Pelton turbine. B. Francis turbine. C. Kaplan turbine. D. Propellant turbine. so ይሄን ሰርቻለሁ በባለፈው ቪዲዮ። this Pelton turbine is it is an impulse turbine. so impulse turbine እነኚህ በሙሉ ሪአክሽን ተርባይን ናቸው። እነዚህ ሪአክሽን ተርባይን ናቸው። but this Pelton turbine is it is impulse turbine. ሌላ ጥያቄ the maximum axial load transfer from compression machine is 10 Newton and here find the allowable dimension for outer diameter D and inner diameter D, small d for a hollow shaft wire 2D which is equal with D or inner diameter or outer diameter is equal with 2 times inner diameter if the material's allowable strength is 360 megapascal and factor of safety is 1. so እዚህ ጋር የተሰጠን ፎርስ ተሰጥቶናል። ሌላ ዲያሜትሮቹ ተሰጥቷል። ዲያሜትሮቹ የአውተር ዲያሜትሩ ኢነር ዲያሜትር ሁለት ጊዜ ማቴሪያል አላውብል ስትሬንግዝ 360 ሜጋፓስካል ተሰጥቶናል። ፋክተር ኦፍ ሴፍቲ አንድ ተሰጥቶናል። የተጠየቅነው አውተር ዲያሜትር እና ኢነር ዲያሜትር ኦፍ ሃሎ ሻፍት so here we have given allowable strengths. ይሄን ጥያቄ ከመስራቴ በፊት ብዙ ጊዜ ሰርቻለሁ። ጥያቄው ላይ ኦር ምርጫው ላይ ተመሳሳይ መልስ አለ የለም ያው ከዚህ ጋር ኮምፔር አድርጋችሁ ምርጫው ላይ ያለውን ሲምፕሊፋይ አድርጋችሁ ትወስዱታላችሁ ማለት ነው። so allowable strength 360 ሜጋፓስካል ተሰጥቶናል። ሴፍቲ ፋክተር አንድ ፎርስ 10 ኒውተን capital D that means outer diameter of the shaft is equal with 2 times inner diameter of the shaft. so require capital D and small d which is outer and inner diameter of hollow shaft. ስለዚህ ይሄን ለመስራት የምንጠቀመው this stress which is force over area and the area of hollow shaft usually this A is calculated as pi over 4 into capital D square minus small d square where this capital D is the outer diameter of hollow shaft and small d is inner diameter of hollow shaft. And when we substitute this capital D which is equal with 2 times small d pi over 4 into 2d square minus d square, and when we simplify the value this area of this hollow shaft is pi over 4 times 3d square. so this is the area of hollow shaft, and when we substitute this area value we have given force and area we have calculated here stress which is force over area which is force F over pi over 4 into 3d square. so here we have stress which is 4F over 3 times pi times d square
and we have force given 10 Newton, and 4 times 10 Newton over 3 pi d square, which is stress. So when we are designing, we have to ensure that the safety of the designed part by comparing the stress which is going to be developed on the part with that of allowable strength of the material. Here we have given allowable strength of the material 360 megapascal, which is 360 Newton per millimeter square. Therefore, we have to compare this allowable stress with that of the stress that we have calculated, which is going to be developed on the machine part. So allowable stress, which is equal with stress over factor of safety. We have given factor of safety, which is 1. And by substituting the value 360 megapascal is equal with 40 Newton over 3 pi d square. And when we simplify the values here by 41, by 49, and here we have 27. When we multiply this part, 27 pi d square, which is equal with 1. So d square, which is 1 over 27 pi, and d, which is equal with radical 1 over 27 pi. And approximately I found the value 0.108 millimeter, and this is small d, this is small d, and capital D is 2 times small d, which is 2 times 0.108, which is 0.216 millimeter. So these values are in millimeter. So here not በዚህ መልክ ነው የሚሰራው። ሜቢ እዚህ ፓርቱ ላይ ሲምፕሊፊኬሽኑን ስሰራ ስላልመጣልኝ ነው። ሜቢ ጥያቄው ላይ ስህተት አለ ብዬ በራሴ እንትን አድርጌያለኝ። So this is the diameter, the outer and inner diameter of the shaft. ቀጣይ for a thick cylinder whose stress conditions using polar coordinate system are related with radial 90 megapascal, circumferential 100, and longitudinal 60 megapascal stresses, determine the equivalent volume-basis equation. The equivalent volume-basis equation is A 50 megapascal, B 25 megapascal, C 36 megapascal, D 76 megapascal. So ይህን ጥያቄ በባለፈው ቪዲዮ ላይ ሰርቻለሁ፣ በት ክሊር ላድርግላችሁ በዚህ ቪዲዮ። ራዲያል ስትሬስ ተሰጥቶናል 90፣ circumferential stress 100 ተሰጥቶናል፣ longitudinal stress 60 ተሰጥቶናል። So volume-basis or equivalent volume-basis stress ነው የተጠየቅነው። ይሄን ካልኩሌት ለማድረግ የምንጠቀመው ፎርሙላ equivalent volume-basis stress, which is calculated as radial stress minus circumferential stress the whole square plus circumferential stress minus longitudinal stress the whole square plus longitudinal stress minus radial stress the whole square plus 3 times shear stress along radial and circumferential the whole square plus 3 times shear stress along circumferential and longitudinal the whole square plus 3 times shear stress along longitudinal radial the whole square. So for thick cylinder under pressure, this part is 0, this part is assumed to be negligible, and this part is 0. So we have given this radial, longitudinal, and circumferential stresses, and by substituting the value, here we have radial 90, this circumferential 100, and the other circumferential 100, longitudinal 60, and radial 90. And by simplifying the values, here we have equivalent volume-basis stress, which is 36.06 megapascal, which is approximately equal to 36 megapascal. Therefore, the correct answer for this question is choice C, 36 megapascal is the correct answer. So ትክክለኛው መልስ ይሄ ይሆናል ማለት ነው። ሌላ ጥያቄ suppose we want to apply the stability criteria for a transient two-dimensional heat conduction problem in a rectangular region that is to be solved by the explicit method. The stability criteria for all interior node in its simplest form is A, tau, which is equal with alpha times change in T over change in X square, which is greater than or equal to 1 over 2. B, tau, which is equal with alpha times change in T over change in X square, which is less or equal to 1 over 4. C, tau, which is equal to this alpha into change in T over change in X square, which is greater or equal to 1 over 4. And D, tau, which is equal to this alpha times change in T over change in X square, which is less or equal to 1 over 2. So let's discuss this theoretically. So here the stability criteria for solving transient heat conduction problem using explicit methods such as forward Euler method involves ensuring that the time step used in the calculation is small enough to prevent numerical instability. So for a two-dimensional problem in a rectangular region, the stability criteria in its simplest form is often expressed using the Fourier number. And the Fourier number is defined as the ratio of the thermal diffusion time scale, which is tau, to the time step, which is changing t. It is usually given by the formula tau, which is equal with alpha into changing t over changing x the whole square. And for stability, the Fourier number must be less than or equals to the certain critical value, typically denoted as FO critical, is Fourier number critical, which is usually depends on the specific numerical method being used. And in this, the simplest form, for the explicit method, the stability criteria typically requires at the Fourier number, which is usually less than that or equals to that of 0.5 for each dimensions. So in its simplest form, for the explicit method, the stability criteria typically requires that the Fourier number, which is less than or equals to 0.5 for each dimension. And this criteria ensures that the information propagates smoothly through the grid during each time step. Therefore, the stability criteria for all interior nodes in its simplest form for a transient two-dimensional heat conduction problem in a rectangular region solved by the explicit method is tau, which is equal with alpha times changing t over changing x the whole square, which is less or equals to 0.5, which means 1 over 2. This 0.5 means 1 over 2. Therefore, the correct answer with this value is this choice D. Choice D is the correct value. So for this question, this is the correct value. This is the correct. So here the stability criteria for all interior node in its simplest form for this case is tau, which is alpha times changing t over changing x square less or equals to 0.2, which means 1 over 2. Next, during which stage of project did the project manager focus on developing the project infrastructure needed to execute the project and developing clarity around the project charter and scope? A, during execution; B, during startup; during completion; and during evaluation. So from this, in which step the project manager focused on developing the project infrastructure needed to execute the project and developing clarity around the project charter and scope? So ይህን ጥያቄ በባለፈው ቪዲዮ ላይ ሰርቻለሁ። ባት አብዛኞቹ ኮሜንት ላይ ጥያቄውን እንዲብራራ ስለፈለጉ ፕሮጀክት ኢንፍራስትራክቸር ኦር ለፕሮጀክቱ የሚያስፈልጉ ነገሮችን ትክክለኛ ኦር ራይት ፕሮጀክት ማናጀር መች ነው ዴቨሎፕ የሚያደርገው፣ መች ነው ሀሳቦችን የሚያመጣው፣ የፕሮጀክት ስኮፑን መች ነው ፊክስ የሚያደርገው። በቅድም ላይም which one is the first step during planning the project በሚለው ላይም ትንሽ ለማብራራት ጥረት አድርጋለሁ። ሶ ለፕሮጀክት የሚያስፈልጉ ነገሮችን በሙሉ አንድ ፕሮጀክት ማናጀር ሴት የሚያደርገው ዴቨሎፕ የሚያደርገው ኦር ፎከስ ሰጥቶ የሚሰራው የቱ ጋር ነው? ፕሮጀክቱን ሲንጀምር ኦር ከመጀመራችን በፊት ነው። ዩዥዋሊ ፕሮጀክት ከመጀመራችን በፊት ምን ነው የምንሰራው? ፕላን ነው የምንሰራው። ሶ በዛ ፕላን መሰረት አስፈላጊውን ኢንፍራስትራክቸር በሙሉ ፕሮጀክቱን ከመጀመራችን በፊት ነው የምናዘጋጀው ማለት ነው። ሶ ዱሪንግ ስታርታፕ የሚለው ትክክለኛው ጥያቄ ትክክለኛው መልስ this the project manager focus on developing the project infrastructure needed to execute the project and developing clarity around the project charter and the scope during project startup. So በዚህ ጊዜ ነው ይሄ ስራ የሚሰራው። the next ይሄንም ጥያቄ በባለፈው ላይ ሰርቻለሁኝ ባት ክላሪቲ ወደ 1500 ፎሎወር ባለበት ኦር መንበር ባለበት ዩቲዩብ ወይ ምን ቴሌግራም ቻናል ላይ ጥያቄው ሲዘዋወር ስላየው ነው ይሄን ከእንደገና ላብራራላችሁ ብዬ ነው። so with the increase in cost of preventive maintenance, the breakdown maintenance cost will be A, increase; B, increase at a faster rate; C, decrease; D, no change. so በዚህ ማብራሪያ ጋር አንድ ላይ አያይዤ አብራርቼ ነበር but አብዛኞቹ ጥያቄውን ከእንደገና እየሰራችሁ ስለነበረ in detail ለማብራራት ፈልጌ ነው። so maintenance cost we have cost of maintenance cost አለ ኦር ሜንቴናንስ ስንሰራ የምናወጣው ኮስት አለ። ስለዚህ አብዛኛው ጊዜ እነኚህ ኮስት ኦፍ አቺቪንግ ፑር ኳሊቲ እና ኦር ኮስት ኦፍ ጉድ ኳሊቲ ኤንድ ኮስት ኦፍ ፑር ኳሊቲ የሚል ኮስት ዲቪዥን አለ። ኮስት ኦፍ ፑር ኳሊቲ የምንለው ኮስት ኦፍ ፑር ኳሊቲ የምንለው አንድን ስራ ኦር አንድ ችግር ካጋጠመ በኋላ የምናወጣው ወጪ ማለት ነው። ኦር ለመጠገን የምናወጣው ወጪ ነው። ኮስት ኦፍ አቺቪንግ ጉድ ኳሊቲ የምንለው ደግሞ በችግር ላይ ከመውደቃችን በፊት ችግሩ ላይ እንዳንወርቅ ቀድመን የምናወጣው ኦር እንዳንወርቅ የሚያግዙ ነገሮች ላይ ቀድመን ኢንቨስት የምናደርግበት ሲስተም ኮስት ኦፍ አቺቪንግ ጉድ ኳሊቲ ብለን እንጠራለን። ስለዚህ ይሄ ፕሪቨንቲቭ ሜንቴናንስ ኮስት የምንለው ኮስት ኦፍ አቺቪንግ ጉድ ኳሊቲ ነው። ፕሪቨንቲቭ ሜንቴናንስ ኮስት ላይ ሃይ ኢንቨስት ብናደርግ ኦር ሃይ ኢንቨስት አደረግን ማለት የማቴሪያሎቹ ኦር የማሽኖቹ ብሬክዳውን እንቀንሳለን ማለት ነው። ዳት ሚንስ ማሽን ብሬክዳውን ሜንቴናንስ ኮስት የምንለው አንድ ማሽን ፌል ካደረገ በኋላ ያን ማሽን ሪፔር ለማድረግ የምናወጣው ኦር ሪፕሌስ ማሽን ፓርቱን ሪፕሌስ ለማድረግ የምናወጣው ወጪ ዳት ኢዝ ኮስት ኦፍ ብሬክዳውን ሜንቴናንስ ብለን እንጠራለን። ስለዚህ አንድ ማሽን ኦር በምንሰራው ስራ ኦር በምንሰራበት ቦታ ላይ ሜንቴናንስ ኦር ፕሪቨንቲቭ ሜንቴናንስ ኮስት ላይ ሃይ ኢንቨስት አደረግን ማለት we are reducing the probability of occurrence of machine breakdown. That means we are decreasing the cost which is going to be invested or going to be expended or breakdown maintenance cost. ስለዚህ በዚህ ኬስ እዚህ ጋር ሜንቴናንስ ኮስት አለ፣ ፍሪኩዌንሲ አለ። ስለዚህ ሃይሊ እዚህ ጋር ፕሪቨንቲቭ ሜንቴናንስ ኮስት ማለት ይሄ ነው። እቺ ቢጫዋ ፕሪቨንቲቭ ሜንቴናንስ ኮስት ነው የምታሳየው። እቺ ጥቁሯ ቶታል ሜንቴናንስ ኮስት ነው። ይሄ ሪፔር ኮስት ብለን የምንጠራው። ስለዚህ እዚህ ጋር ፕሪቨንቲቭ ሜንቴናንስ ኮስት ሃይ ከሆነ this breakdown maintenance cost or breakdown የማሽን ብሬክዳውን ሎ ይሆናል። እዚህ ጋር ነው ያለው። that means breakdown maintenance cost በጣም እየቀነሰ ይሄዳል ማለት ነው። በጣም እየቀነሰ ይሄዳል። but እዚህ ጋር preventive maintenance cost ሎው ከሆነ preventive maintenance cost እዚህ ጋር ሎው ከሆነ that means ማሽኑ ብሬክ የማድረግ probability high ይሆናል ማለት that means we have to invest high breakdown maintenance cost ማለት ነው። ስለዚህ ይሄ ነው ምንም ቪጂታ ያለውም preventive maintenance cost በጨመርን ቁጥር breakdown maintenance cost እየቀነሰ ይሄዳል ማለት ነው። ይሄ ነው መልሱ። As a question, if two pumps are connected in series, the performance curve would be A, the sum of the head of the two pumps as the same flow rate, B, the sum of the flow rate of the two pumps as the same head, C, the sum of the head and the flow rate of the two pumps, D, none. So here we have two pumps connected in series and we are asked to differentiate the performance curve for these two pumps. So when two pumps are connected in series, the performance curve is such that the sum of the flow rate of the two pumps has the same head. That means here this B is the correct answer. Which method of welding operation is illustrated in this figure? So በዚህ ፊገር ላይ የተገለጸው welding operation type ምን አይነት welding operation type ነው? ይሄ ነው ጥያቄው። So here A, shielded metal arc welding, B, spot welding, C, laser welding, and D, gas metal arc welding. So በዚህ ኬስ የምንጠቀመው ኦር የተጠቀምነው ምን አይነት ዌልዲንግ ታይፕ ነው የሚል ጥያቄ ነው። ሶ በዚህ ኬስ የተጠቀምነው ጋዝ ሜታል አርክ ዌልዲንግ ታይፕ ነው የተጠቀምነው። ኦር በዚህ ፕሮሲጀር የሚሰራው ጋዝ ሜታል አርክ ዌልዲንግ ነው። ሶ ጋዝ ሜታል አርክ ዌልዲንግ አብዛኛው ጊዜ በዚህ ሜካኒዝም ነው። in case of this gas metal arc welding there is DC or AC power supply, there is እዚህ ጋር consumable ኤሌክትሮዶቹ እዚህ ጋር ሰፕላይ የምናደርግበት in the form of wheel እዚህ ጋር አለ የተጠመጠመ then feed የምናደርግበት እዚህ ጋር weld የምናደርግበት ፓርት አለ። then there is inert gas also, there is nozzle, there is wire guide, there is inert shielding gas also, and there is electric arc here which is created during this welding, and there is also workpiece here. so በዚህ ኬስ or በዚህ ኢሜጅ ላይ or በዚህ ስኬች ላይ ያለው or በዚህ ፎርም የሚሰራው ዌልዲንግ ታይፑ ጋዝ ሜታል አርክ ዌልዲንግ ነው። ስለዚህ ይሄን ሜቢ በተለያየ ቦታ ላይ ሪፈር ማድረግ ትችላላችሁ አድርጋችሁም በመጽሐፍ ሊሆን ይችላል የተለያዩ ዩቲዩብ ቪዲዮዎች ላይ። ሶ ለአሁኑ ያለኝ ቪዲዮ ይሄ ነው። ቀጣይ ላይ ካልኩሌሽን ፓርቶች በጣም ዲቴል ካልኩሌሽን የሚፈልጉ ፓርቶችን አንድ ላይ ለይቼ እየሰራው ነኝ። በቀጣይ ቪዲዮ ላይ እሱን አፕሎድ አደርጋለሁ። እስከዛ ግን ይሄን ቪዲዮ እየተጠቀማችሁና ለጓደኞቻችሁ ሼር እያደረጋችሁ ለኤግዚት ኤግዛም ዝግጅት ላይ ቢያንስ አንድ ስቴፕ ከፍ እንድታደርጉና ቫልዩ አድ እንድታደርጉ ወለኝ። ለቻናሉ አዲስ ከሆናችሁ ቻናሉን ሰብስክራይብ አድርጉ፣ ቪዲዮቹን ላይክ አድርጉ፣ ዜን ቪዲዮቹ ላይ ኮሜንት ጻፉበት። ዜን ለጓደኞቻችሁም ሼር አድርጉ። እኔ ጋር ለመድረስ የምትፈልጉት at any time በስልክ ላይም በኢሜል ላይም ቀጥታ እኔን ኮንታክት ማድረግ ትችላላችሁ። በቀጣይ ፓርት መጣለኝ። እስከዛ ደህና ቆዩ።